Hey, welcome back. You ever see a poll in the news and just think to yourself, wait a minute, how can they possibly know what an entire country thinks just by asking 1,000 people? I mean, it really does seem kind of like magic, right? Well, today we're going to pull back that curtain and look at the powerful science that makes it all work, sampling. This is the big question, isn't it? It just feels wrong. How could such a tiny fraction of people be a reliable mirror for the whole group? Well, it turns out, and this is the key, it's not really about how big the population is. It's all about the science behind how you pick your sample.
All right, so here's our roadmap. We're going to start with a real-world puzzle, then we'll uncover the secret sauce that actually makes sampling work. After that, we'll get our hands dirty with the recipe for figuring out sample sizes, we'll run some numbers, and then we'll hit the reality check that every researcher has to deal with.
So let's dive right in with a real-world puzzle. And look, this isn't just about some big national poll on TV. This is about decisions that affect our actual communities every day.
Just take a look at this example from Los Angeles. They wanted to evaluate their 911 service, a system that serves millions of people. And they figured out they only needed to successfully survey 900 residents to get the data they needed. Now that wasn't a guess. That was a calculated statistical decision.
So how on earth is that possible? Well, the whole idea behind it rests on a really simple but incredibly powerful idea. The difference between the group you want to know about and the group you actually talk to.
You know, the easiest way to wrap your head around this is the soup analogy. You don't have to drink the entire pot of soup to know if it needs more salt, right? Of course not. You just need one good spoonful, assuming you've stirred the pot well. That spoonful, that's your sample. And the whole pot of soup, that's the population.
And, as you might guess, statisticians have a specific language for all of this. When they're talking about the entire pot of soup, the whole population, they tend to use Greek letters, like mu, for the true average. But when they're talking about the spoonful they actually tasted, the sample, they switch over to Latin letters, like X bar. So that true value for the whole pot, that's what's known as a parameter. Think of it as the real number we're hunting for, the actual capital T truth for the entire population.
And the number we get from our little spoonful, well, that's a statistic. It's not the absolute truth, but it's our best educated guess at that truth based on the real data we were able to collect.
Okay, but if a statistic is just a guess, how good of a guess is it? That's where the confidence interval comes in. You know when you hear a news report say a poll has a margin of error of plus or minus 3%? This is it. This is that range where we're pretty darn sure the real number, the parameter, actually lives. So that brings us back to the big question. How do researchers know if they need a tiny spoonful or a giant ladle? How do they pick that magic number, whether it's 900 or 1,000? Well, it's not just a gut feeling. It's a recipe that depends on just 3 key ingredients. And that's it. These are the only 3 things that matter. First, how precise do you need to be? Second, how confident do you need to be in your final answer? And third, how different do you think people's answers are going to be from each other? Now notice what is not on this list, the total size of the population. Kind of mind-blowing, right?
All right, let's stop talking theory and actually put these ingredients to work. We're going to see how they build into a real calculation by following a department store that's trying to figure out what its customers are spending.
Okay, I know this looks a little intimidating, but don't worry. This is basically the blueprint from our source material. All we have to do is follow the steps in that first column, the one for means, and we'll see exactly how the store finds its magic number.
So here are the ingredients for our recipe. First up, precision. The store decides it's okay if their final number is off by about $5. Second, confidence. They want to be 95% sure of their result. In the world of stats, that corresponds to something called a z-value of 1.96. And finally, variability. Based on past data, they guess that people's spending habits vary by about $55. And this is where we put it all in the blender. The formula looks like this. The sample size you need, N, is just your confidence level squared, times your variability squared, all divided by your precision level squared. We just have to plug in the numbers we already have. And when you run those numbers through the formula, you get 464.83, which of course we round up. The store needs to get 465 completed surveys. That's it. That is the magic number they need to be 95% confident that their estimate is within $5 of the real average spending.
But, and this is a huge but, that's 465 completed surveys. And anyone who's ever tried to get information from a list of people knows that actually getting that many responses is the real challenge.
This is the million-dollar question in real-world research. You can have the most perfect, beautiful statistical calculation in the world, but it means absolutely nothing if you can't actually get the data from people. And this challenge has a name: non-response.
So to solve this, researchers have to think about two more things. First is the incidence rate, which basically asks, of the people we contact, how many are even the right people for this survey? And then there's the completion rate, which asks, okay, of those right people, how many will actually finish the whole thing?
This is the reality check formula. You take your perfect sample size, our 465, and you divide it by the percentage of people who are eligible and by the percentage of people who are willing to talk. And let me tell you, if those rates are low, the number of people you have to try and contact absolutely skyrockets.
And because getting responses is so tough and so critical, researchers have this whole toolkit to try and boost those numbers. They'll send out letters beforehand, maybe offer a small gift card, or try calling at different times of day, anything to improve their chances of getting a complete survey.
So the really crucial takeaway is this. That statistically pure number of 465 completed surveys could easily require an initial contact list of 1,000, 2,000, maybe even more people in the real world just to hit that goal.
And that really leaves us with a final thought, doesn't it? A poll might report a sample size of 1,000 people, but that's just the headline. The real story is the statistical rigor that makes that number meaningful, and the immense, often completely unseen effort it takes to get even those few voices heard. What we see in the end, well, it's truly just the tip of the iceberg.